Good morning slash afternoon slash evening, everybody, wherever you're watching. Welcome to our March 2026 Akka.Management Community Stand-Up. My name is Aaron Standard, and I'm joined here by my colleague, Gregorius Sodharmo. Gregorius, we got a lot of stuff done since our last meeting, didn't we?
Yeah, sure did.
Yeah. So we've got a very exciting presentation today from Lara and David at Grimmloch about their MMO. So we're going to try to get through all of our actual Akka.Net updates rather briskly here so we can make as much time as possible for their much more interesting and exciting presentation compared to just us going through our release notes. So let's go ahead and dive in and talk a little bit about some of our recent Akka.Net releases here. Couple of big things. First, we did Akka.Net 1.5.61, and this includes a number of important Akka.Cluster.Sharding and Akka.Cluster fixes. So a lot of these fixes are super edge casey, but not entirely. This issue right here that we resolved, the shard failures during scale up, I'm going to pull this up here. We basically kind of ported a missing feature from Peko, which is the Apache 2.0 fork of the original Scala Akka, where more or less the handoff system for redistributing shards could miss signals during rebalancing that could result in essentially a split brain per se here. Now, I haven't seen a lot of reports around this in production. We had a split brain issue a couple of years ago that was related to cluster singletons, and that's been fixed for a while. But this still had the potential to do that. And the issues I kind of saw here were more related to, if we take a look at the original GitHub bug, where it looks like the handoff fails indefinitely. This is sort of the signal you'd want to look for inside your logs if there was a problem. That all got fixed in 1.561, along with a couple of other little small issues here. This bug was also kind of an important sharding fix. This could result in a split brain too. This was a bug fix submitted by Matt Constantus from the Microsoft team. So that was nice. We appreciate that. And we also fixed a couple of issues with the logging system and a couple of other little quality of life issues here. And then we did 1.562, which was a pretty small Akka.Net release. The bug that we were fixing here is a bug that Gregorius had previously fixed on our traditional logger. But now that we have the new semantic logging system, we had to go and unfortunately rediscover and refix this bug, which is if you have a malformatted log string, we need to have some way of capturing that and making sure that it gets represented real easily inside the log system so you know where to go fix it. So that got fixed in 1.562. So if you have a missing log format string somewhere, this will help you catch that more easily now. Let's see. Rest of the issues here. Gregorius, do you want to talk a bit about these Akka coordination problems that, in fact, you know, we have a fix that is so new, we didn't even make it into the release notes here. The 1.562 release. Yeah, you probably published this like 2 days after, like 2 hours after I wrote these release notes. You want to talk about this real quick, Gregorius?
Yeah, sure. Let me pull that up first.
Well, this is
I didn't have them up because it wasn't in the top note.
Yeah, no worries. Well, I've got it on screen here. But basically, you had 3 bug fixes all around leases in Akka coordination. This was the Azure SDK bug we had to work around. That one. And then these 2 bugs in the actual lease implementations themselves. Let me go ahead and get them open real quick. So all 3 of these have been fixed as of Akka.Management 1.562. Why don't you give us the 30,000 foot view of like the problems these caused and how it's fixed?
Well, the create if not exist async bug is kind of funny because if you look at the method name, is create if not exist, but the method can actually raise a container did not exist exception, which is a bug in the SDK itself.
Yeah.
But, so we did a workaround around that, so it should be working now.
And then these other 2 bugs that you and I worked on The heartbeat surrender bug and the premature lease acquire. These were bugs with like the Akka lease finite state machine that could result in leases hanging around indefinitely. These have been fixed. So if you guys use leases for Akka.Cluster.Sharding, cluster singletons, or the split brain resolver, this is like a pretty important upgrade. Actually, you should probably plan on upgrading this soon. This basically makes the whole system much more robust than it used to be. So that's a good one there. Let's see, another big release that we took care of. Let me go ahead and grab SDK bins release notes for this real quick. So we made a pretty big set of improvements to Phobos, actually, is one of the things that we did here. One of the most annoying features that people complained about is that Phobos used to have to copy all your log. Like if you use the Akka.NET iLogger, we would copy that output as events into the Phobos traces that would be produced. And that's kind of a holdover from before OpenTelemetry existed. That was the only way to correlate that data when we were doing open tracing back in like 2018, 19, 20, 21, before we really supported OpenTelemetry. That's all been removed now, and we support proper like log trace correlation as first-class citizens using metadata. And we have a whole page that details how to do this now, how it works, shows some screenshots depicting the examples there. So that's something that we'll probably do a dedicated email about at some point in the future. We just shipped this a week ago, so we haven't quite gotten around to that yet. But that's a nice quality of life feature that'll result in a lot less data being collected by Phobos, and the data is more easily queryable, and it plays nicely with like semantic variable extraction. Sorry, semantic log value extraction in platforms like Seek, for instance. So overall, really nice set of additions to the observability suite here. No big updates on Akka.NET 1.6 this month. We've primarily been focused on shipping some other projects at the moment. If you followed me on Twitter, you probably saw the TextForge announcement yesterday. Maybe we'll talk about that a little bit later this year during a show and tell presentation. But that's primarily what we've been focused on. We should have some new updates on Akka.NET 1.6 probably in our April stand-up, would be my guess. So with all of that being said, we're going to go ahead and shift gears now to our show and tell featuring Lara and David Rivera. Lara and David, me and Gregorius are going to fade into the background here, but we'd love to have you introduce yourselves, and we will slink off and let you get on with your presentation.
Well, welcome everyone. Thank you for coming to see what we're doing. My name is Lara Rivera and my husband David is here. My husband is the architect of this, so he will be doing the bulk of the presentation. I'm just going to introduce the project and kind of let you know how we got here. This is a game written by role players for role players. My husband and I met playing Ultima Online more than 25 years ago. I was on the East Coast, he was on the West Coast. We eventually ended up getting together, getting married, raising two beautiful children. And we've been running roleplay communities that entire time. Even prior to that, we were involved in live action roleplay and the Society for Creative Anachronism. We are really into storytelling. And my husband has wanted to do this for a very long time. And I kept telling him, no, we weren't ready. The technology wasn't ready. We needed to really wait until we could do what we wanted. And that was one goal, narrative emergence. For role players, we didn't want a game that involved using dialogue trees or pre-scripted quests. We wanted a player to drop into an environment and be able to be completely immersed. Luckily, with the introduction of large language models, AI, we're able to do narrative emergence because we can utilize this to understand a player's sometimes messy, complicated, drama-ridden roleplay post, send it into a GOAP so we have deterministic behavior for our NPCs, and output it into a format that will create natural dialogue, personality markers, so that the NPCs feel alive. And being able to do that is a dream of ours. This is definitely a passion project. Our community has been together for most of those 25 years, and everybody's really excited to have a game written for them. We've never had that before. Ultima Online certainly had a big role play community and was well known for being an active role play space. Neverwinter Nights introduced role play and setting your own story and game master led, and that was one of the other tools that we got. But since then, most role players have had to try to elbow their way into MMOs, into sandbox games, and it's never really been a good fit. One of the things that I want to introduce on this is the complexity of managing what is essentially a live simulated world where every NPC has autonomous behavior, where quests and storyline developments are in and of themselves autonomous. They respond dynamically to players. That set an expectation of trying to track these NPCs or actors in your tech to figure out where they go. And that's really what David brings to the table. My husband was one of the lead developers on the BNSF's positive train control system, which is a system that tracks trains live. It's a mission critical system. If trains crash, people get hurt. And he's bringing that same technology, Akka.net, Akka.net Persistence, what we are using, to our game platform. So it's stable, reproducible, and I'm really excited for him to tell you about some of the interior of what we're doing. Thank you.
All right, so I think that's my cue. Yes, I'm David Rivera, and yeah, I'm going to be taking you through a little bit of kind of how we've architected this. Grimmloch is still a very much in deployment game. We're not planning on releasing potentially at least until next year. But we have come a long ways in almost, I guess it's probably been about 8 months or so, somewhere around there total, since we kind of came up with the idea. But let's take a look here. Let me bring up my slides and see if, there we go. All right, so as I said, we did decide, I decided, and I've been wanting to do this for a long time, decided to use Akka as the complete backend for the server for the game. Did that for a number of reasons. One of them, my familiarity with it. Another one is just the robustness and ease of integration that I have discovered while using Akka.net, both at work as well as in other personal projects as well. And so with that in mind, we decided that we wanted everything to be in one big world. We didn't want to do shards or servers or anything like that. We wanted everybody to be in the same world, kind of along the same lines as EVE Online does, where everybody's in the same world, so to speak. And in order to really do that, I knew that Akka.net would be very good for being able to cluster the system and be able to spread the load across multiple servers relatively easily. So what I designed out was actually a single executable that runs on each node in the cluster. And that single executable can run any one or all of the 3 roles that we currently have in the system. Those three roles, as you can see here, are the relay, the game server, and the LLM server. The relay role is responsible for handling client connections from the Unity game client. They connect into the relay server. The relay server is connected in the same actor system as all of the other roles and can talk directly itself to the game server or the LLM server, and they can talk to the relay as well. Relay's primary purpose is really for just relaying messages back and forth between the server and the clients. The game server role is where basically all of the game logic lives. How NPCs operate, how the maps are handled, how moving around of characters occurs, interacting with NPCs, the combat, the dynamic weather system, all of that is handled server-side via the game server role. As part of that, we have taken advantage of Akka.net's sharding capabilities so that most actors that handle either entities in the game or maps or locations, they are split across all of the nodes in the cluster automatically via the Akka sharding. That provides us obviously a whole lot of functionality. It allows us resilience for if a node goes down, then those NPCs and maps and everything that the game server is handling on that node automatically get pushed over to other nodes within the cluster so that we have as little downtime as possible and as little having to manually handle, oh, the game server died, let's go bring it back up, etc. It will automatically do this for us in the background to a large degree. The LLM server role allows us to host local LLMs on the same machines that we are running the game server. It also allows us to run it on other machines as well, because we can run the executable on those machines and only activate the LLM server if we want to. But this was a system I designed myself that allows us to split the LLM processing across multiple machines and have the LLM requests get sent via various different algorithms. I've got in there round robin, where it will just send to the next node in the list any LLM requests, and then locally on that node, the LLM will process the request and return the response back to the original sender. We are using pretty small models. We're able to get by with pretty small models in this, and so most of the machines that are in the cluster can run these LLMs as well as the game service.
Now, you mentioned in your literature that these are running on Mac Minis. Is that what's serving the LLMs there?
That is, yes.
Yeah.
They are. We are currently running Mac Minis. We'll potentially be putting some Mac Studios in there as well if we decide we need bigger models. But yeah, the back end is entirely running on Mac Minis.
Now, I know this isn't an Akka.net question, but it's been a hobby horse for me. I've been working on trying to get local LLM inference going inside our offices here at Pettibridge. Gregorius can attest to how much I have bored him with extensive descriptions about GPU configuration and PCIe intercard bandwidth and all that stuff. So what models are you actually using currently for this? And I know you might be getting to that. So if you are, I apologize.
That's all right. We're running through a couple of different ones. We've been using Mistral as part of our testing. We've been using Quen as part of our testing. Early on, we used some of the Llama models as well as part of our testing. We haven't come to a final decision on which one we're actually going to be using, but we will probably be using multiple because different models are good at different things. We have models that are being called to determine what somebody's role play post is actually about, what the intentions of the post are. And then we use LLMs for generating the NPCs dialogue responses, their own role play responses. And these two activities, different models are better or worse at the various different activities that we're doing. So we'll probably end up using a couple of different ones.
May I jump in for a moment?
Absolutely.
We discovered early on, and anybody who's played with some of the other AI chat programs, that using an LLM to host the actual storyline is unsustainable. They hallucinate, they go off track, they can't keep the bigger thread in mind. So we learned very early on that was never going to be the way we wanted to design. So these LLMs that we're picking are doing very small, specific jobs. They only have to be good at writing dialogue, or only good at determining intent, or only good at making a decision-making criteria. I use social penetration theory as part of our reputation system. And so it only needs to evaluate that. We don't use any big models. We don't have to make any big calls. So it really does make a difference for us by the model choice. This system, this design supporting GOAP with models on either end is far less likely to randomly run off and introduce mysterious strangers with unknown letters.
Yes. Yeah. We've got a number of what we call guardrails in place to make sure that the LLMs don't go off into the weeds and go off onto strange tangents and hallucinate like crazy. That's been a big part of our effort in designing and testing and all of that, is getting those guardrails to really keep the LLMs on track and keep them realistic and non-hallucinatory. They still obviously hallucinate to some extent, but we've put in guardrails to reduce that a lot.
The goal is to serve the player's story, to
Correct.
be there to support what the players are doing, to engage in the player's action, and move the whole story along together with the players, not to be the one in charge.
Correct. Right. All right, I'll go ahead and move on to the next slide here. So this is talking about the cluster sharding that I was talking about before. The majority of the actors that we're actually using in the background, other than transitory ones, take advantage of the sharding so that we can have that resilience and backup for if in case the node fails. Like you can see here, our NPCs, the player accounts. On our maps, we have what are called locations, which is just an area of the map that is a managed location that can do things like the location itself can interact with the player and the players can interact with the location. And so all of these are sharded across the cluster via the game server role. We've kind of defaulted it currently to the 100 shards for each. We haven't yet done, I'm currently working on a load test harness to be able to load test it and kind of see where we actually want to end up with how many shards that we have and actually how many machines that we have. But this does allow us to build out the cluster and spread the load across that cluster pretty reasonably. All right. So event sourcing. So I designed the system to be based on event sourcing. And we are using Akka.Persistence to handle that. There are a number of reasons for doing so. One of them is really helpful during development in that you get almost a log of everything that occurs, as well as when it occurred and why it occurred. This helps me tremendously in hunting down bugs, as well as in testing with our interactions with the NPCs to see where and why an particular NPC reacted a certain way. Things like that. It provides a lot of that functionality. In addition, kind of as presented here, it allows us to take advantage of the sharding to a degree where if the actor does die on one node, we know that the actor, when it loads up on one of the other nodes in the cluster, will be able to read that event journal for that particular actor and be right back where it was and be able to start handling requests again immediately, right back in the state in which it was previously. That helps a lot with the architecture, allowing us to be very, very resilient and provides not exactly an automatic, but a process in which we have to do much less manual things like restarting of nodes, unless obviously it's a hardware issue, things like that. But it
So a question I wanted to ask about this with
Mhm.
respect to, again, this is another LLM adjacent question, which is, so I've been doing a lot of work on a project that's currently private where I'm using Akka.Persistence 2 and event sourcing for storing basically chat histories with LLMs, where it's all the different turns, whether it's from the LLM's output or user input, or whatever. I kind of have it all saved as sort of a append-only log with Akka.Persistence. Are you using something similar here for, let's say, the areas where you need to, feed data to the LLMs for synthesizing story or decisions or dialogue or relationship orientation, that sort of stuff too?
Yes, we absolutely are. That is one of the ways that we are storing data and being able to get it to the LLM. We also have a RAG system where we can do RAG data lookups for, game lore, area lore, NPCs, backstories, and
Oh,
all
cool.
of that is all in there in the RAG system, so that we can go grab it and provide it as additional context to the LLMs.
Got it. That's all. And is this all done on top of like Microsoft.extensions.ai, or are you using some other like agent interface?
I am not. I did start out using what was that one Microsoft had at first, but they are now
Semantic
deprecating it.
kernel.
Yes, semantic kernel. I did start out with semantic kernel, but it wasn't as flexible as I really wanted it to be. So we actually just ended up kind of building our own on top of the OpenAI SDK.
Yeah, that's
This.
kind of the direction I ended up taking too. Someone asked me why I'm not using the new Microsoft Agent framework for my stuff, and I replied to them. I said it'll be dead and replaced with something else in 6 months.
Very likely. Very likely.
Yeah.
Yeah. I
So
did play around with it a little bit as well, but I still didn't like it very much. So,
understood. All right, please keep going.
absolutely. All right. So, next slide. These are kind of some examples of the different event types that get stored and reread in the core NPC. Handles various different things. Our GOP system, which each NPC has a GOP engine that helps it decide what it's going to do. Is it going to go move over here? Is it going to go try and find somebody to talk to? Is it going to, the various different actions that NPCs can do, as well as the GOP system helps as one of our guardrails for the LLMs as well when interacting with an NPC. we have come up with a GOP system to help with that as well. Kind of helps us keep it on the rails somewhat. And then we have a full relationship system where NPCs can have relationships with other NPCs as well as the players themselves. So kind of one of the interaction features of the game is that players can build their relationship with all of the NPCs. And that relationship is directly with that particular NPC. That then also filters up to things like factions and things like that. So, and that's how you often get a relationship going with a faction as well, is if you have involved yourself with a bunch of NPC members of a particular faction, that's going to raise your faction level too, because you are interacting directly with their members. And this can go both positive and negative. You can have a positive relationship with an NPC, and you can have a negative relationship with the NPC as well. And in addition, the NPC can have a negative or positive relationship in how it views you as well. And
That's one of my favorite things. When you're talking to a chat, it's a captive audience. You can just keep making it talk to you. Our NPCs will walk away, or if you push too far, attack.
Yeah, they can trust you, they can distrust you, they can think, oh no, you need to leave this establishment now. They can have all kinds of different positive and negative reactions.
So from an Akka.net actor hierarchy perspective, I'd imagine you would have to instance each of these NPCs against each player, right? So, or how does that work?
No, we have a single, we have I'll actually on the next slide, I believe, we'll get into kind of that hierarchy and how that works.
I'll hold my questions then.
Okay, all right. Well, I guess we can go ahead and move on to that slide then. All right, yeah, the NPC actor is the example that I give here for kind of how our hierarchy works. So we have an NPC actor, which is the kind of overall orchestrator, if you will, of handling an NPC. And underneath that, we have child actors that handle different things. Our NPC awareness actor tracks who's nearby, so that the NPC can know who's nearby and respond to things or interact with them as it feels it needs to. We have our NPC emotional actor, which stores mood and stress and kind of how they're feeling at the moment, which changes over time, as well as with interactions with players and other NPCs. We have the conversation coordinator, which handles overall conversation with the NPC. But as you can see, we also have a per conversation actor that is created on demand to handle an individual conversation with a particular player or NPC. And then our last one, we have the NPC autonomy actor, and this is kind of where most of the GOP for actions, what the NPC is thinking it needs to do in any particular time. That's where that primarily occurs.
Here, oh, sorry, go ahead.
We're demoing the combat system on Saturday, and I know that's also obviously a GOP because that's what GOP started with.
Correct.
Is this another node under this, or is that a completely separate system?
It is another additional actor that has its own GOP system. So it's kind of interesting. We have the GOP there's multiple GOP systems that kind of interact with each other a little bit. There's the core GOP system, which is what the NPC autonomy actor contains. And then off of that, we have a GOP system for combat. We have a GOP system for conversation. We have a GOP system for whether or not this particular NPC is participating in a quest and what it's supposed to do in that quest, information it's supposed to have, stuff like that. And so the primary gope of the NPC, when we receive messages that relate to these other things like combat or conversations, will hand off processing to that gope system so that it can process and do what it needs to do. And if, for example, if it handed off to combat and combat gope is handling all the combat, once combat is over, it returns control back to the autonomy actor, and it is now the primary gope system for deciding on what it needs to do.
I have a really silly sounding question. What is GOPE?
GOPE is goal-oriented action planning. GOPE has been around for a number of years. I forget the name of the game. There was one game that came out a number of years ago that kind of did this first. Fear, yes, that was it.
Gotcha.
And it's a way of creating AI for characters in game, for NPCs.
Like, I see you've got a star search highlighted there on the planner actor. At least I assume that's what that is. Like, I remember learning about that in my algorithms course in college. And they mentioned it specifically for things like path planning, for being able to have NPCs move in video games and things like that. No, this is, and I think conceptually I get your model now of how you organize the NPCs relative to the players. It's an MMO, obviously, right? So you don't shard the instance of the world per player. The whole point is to have all the players in the world. And instead of having a individual actor per like a tuple of NPC to player, that sort of relationship history of that player is something that's retrieved on demand when that player is interacting with the NPC. That's how you design
exactly.
it.
Yeah,
I'm with you now. Got it. That makes sense.
Yeah, we keep track of all the relationship data in the database, and then whenever an interaction begins, we grab that so that the NPC knows what it thinks about this player currently at that moment in time. All right. So is there anything else here? Probably not a lot. We're using one-for-one strategy. When a child terminates, it gets recreated automatically by the parent. Pretty standard stuff there. So I'll go ahead and go to the next. So we have what's called a spatial index actor. And there are a number of actors that use this stash pattern. For people who may be familiar with it, it's the I stash or I have stash interface that you can add to your actors. And this allows us to, especially for the spatial index actor, the spatial index actor is responsible for holding the kind of nav mesh data for a map, for a given map. And it loads that in when the spatial index actor is instantiated. And that takes a few seconds, not terribly long. It's pretty quick. It's a pretty small amount of data. But one of the things that we ran into was the potentiality for requests on the spatial index occurring before it has finished loading and preparing that data so that it can respond to the requests. And so we use the stash pattern for that, so that any messages that come in while the actor is still kind of warming up, doing what it needs to do in order to be able to process the messages, a message will come in and it will go into the stash, which is kind of
like the back end equivalent of a loading screen.
Yes, exactly.
Yeah. Yep.
Exactly.
Yeah, it makes sense. Yeah.
Right. And then when the actor has finished doing what it needs to do and it's ready to actually start processing messages, it then pulls all those messages out of the stash and starts processing them. And any additional messages that come in still get processed as normal. We have a number of actors in the backend system that actually do this, because it's a very easy, surprisingly easy way to implement this functionality. And I'm actually very glad that it is included in Akka.net.
I'm trying to remember the name of the Postgres plugin for doing spatial indices. Maybe they don't need a plugin anymore. Maybe it's built in now. I don't remember.
There is a plugin for it. I'm not remembering what it is off the top of my head. I played around with it a little bit because I thought about using it in the database, but I ended up not using it because we didn't need the full spatial functionality there. Doing it this way, kind of like as it talks about here, we're hashing the cells in the map, and so it makes it a very quick lookup.
Makes sense. So basically, all the actual in-world sort of locations are all stored inside actors then primarily.
Correct. Yes.
Yeah.
Yeah. The world itself is built up of islands, individual islands in the Sea of Dreams, and so each island is its own separate thing. But we've also split each island up into multiple zones, and each one of those zones is a separate map that players go into and are instanced into.
Yeah, it makes sense. And stashing and behavior switching, I got to imagine, get used all over the place inside the system.
Oh, yes. Oh, yes. It is used pretty heavily.
Yeah. All right, keep going.
All right. All right. So just to kind of go over what the kind of the whole stack here is so far. It is all based in .NET 9. All the code is all C# code that's being written. We're obviously using Akka.net along with that to provide the vast majority of the functionality that's actually being implemented for the game. The database backend is Postgres with pgvector for doing our RAG data lookups. We use that for both the event store as well as the read models and other data that we also store there. Some of it's for configuration, various different things. We actually are not using Kubernetes. We are using HashiCorp's Nomad and Console for running this in the background. And there were a couple of reasons for that. One of the reasons being definitely at the time, and I'm not sure how far it's come along, but definitely at the time, calling LLMs from Kubernetes, setting up the whole GPU pass-through and all of that was still kind of getting on its feet a little bit. And then we also made the decision, as we talked about earlier, to go with Mac Minis and Mac Studios as the back end for this, so that we could take advantage of the same machines for LLM processing as well as the game server processing. And running Kubernetes on a Mac means we are running it in a container. And containers on Mac do not run natively. They run through Docker container or some other container setup that runs basically as a VM on top of the operating system. And I didn't want to have that layer in there. I wanted to be able to run the actual executables natively on the machine. And so Kubernetes was kind of an overkill for doing that, because it really is designed for containers primarily rather than managing processes. And the combination of Nomad and Console definitely are a simpler, easier to manage way of doing that.
I was gonna say, so no, I'm not that familiar. I'm familiar with Console for service discovery. Not that familiar with Nomad. So is that basically is that orchestrating little, basically just independent processes with managed lifetimes directly on the bare metal? Is that how that works?
Yes, yeah. Nomad can do containers just like Kubernetes can, but it can also it's got support for running bare executables, and running various other different things. It's got different plugins for being able to run different types of processes through different types of engines. And yeah, we're using its bare executable running part of that.
Makes sense. And then for your serialization here, I noticed you picked Message Pack. I don't know if you caught our community stand-up last month, but we're basically working on a code gen message pack serialization system for Akka.NET 1.6 to basically kind of make that the official standard way of doing things going forward. That's kind of our replacement for Newtonsoft.json, really, is what that's all about.
Nice.
So you're skating ahead of the puck there, which is good. And then in terms of your sort of infrastructure for running this when you're ready to start serving live customers, you get a colo, the Mac, your Mac minis, or what's the idea behind that?
Yeah, the goal will be co-location for those Mac minis. We've got a couple different hosts in mind for setting that up and getting that running. But yeah, that is definitely the plan.
So co-location is absolutely crucial. Back when we were running our servers in the early 2000s, we had some very exciting times with guinea pigs who got loose and ate through cords.
Yeah, we were hosting the server in our house and over our. I think at one point we had a T1 connection going back when that was kind of a thing, and yeah.
Or toddlers with sticky fingers who like to press every button. So there used to be the Katrina effect, which got only funnier after the hurricane because my child's name was Katrina, and just that's it. Off goes the server.
So my father's an internet entrepreneur and has been doing that since like the 1990s, and they had relocated to a basically a real professional sort of hosting facility that boasted redundant power supplies, internet connections, and this was like a $500,000 build that they did to go ahead and move all their servers into it. And the system goes offline within about a month of the moving in there, and like they notice their DNS failover kicks in and everything. And the head of IT for the company contacts the people running the network operations center there and asks, hey, you're supposed to be totally triple redundant against all this stuff. What happened? And they sent him a photo back, the head of IT, of a charred raccoon corpse that had chewed through one of the power mains going into the facility and caused a short in the primary power delivery system for that area of their facility. And then they mentioned, and then the backup system was never properly tested, so it didn't come online. So, critter incidents with data centers can happen even at production scale. Just wanted to share that story. Yeah.
You're not reassuring me.
I had I posted something on Twitter maybe a year ago. So like every September or October, Amazon's giant Virginia data center, that's US East 1, always seems to have some sort of global outage right around September or October. And I tried putting together a chart showing if this is like squirrel breeding season when this is all happening here, for if they've got varmints in the data center up in the woods in Virginia there, but no. Well, no, I think this all sounds very exciting, and I'm really interested in seeing what the game is actually like when it goes live. And we've got some lot of people in here who are a lot of people in here who are rooting you guys on. We go and put some of these comments up.
Oh, Tim.
Yeah.
Hey, Tim. Hey, Jason.
But I think this is a really exciting presentation. It's a great use of Akka.NET. Gregorius, our resident video game developer here. Do you have any questions or comments for him?
Oh, lots, but I think it wouldn't fit in this format, so I wouldn't.
I'd say just drop one even, that you think would be good for the folks in the audience to hear, and then we could leave it at that.
Okay. Well, classically, an MMORPG is practically an instance story for each player, where then player converge into a single point, like a battle or a big reveal or something like that. Uh, since all of your story are generated, how would that work?
This actually runs more like a massive tabletop campaign where every player is participating in the same storyline. The community as a whole is moving towards and solving shared storylines. There are individual quests, but they are designed more like choose your own adventures, so they're on demand. You'll be able to go and ask uh, a quest to be generated for you. So if you want to go and find your holy sword, you will be able to interact with a widget that will ask you some questions about what kind of quest you're looking for your holy sword, and it will make one for you to go through either personally or with your adventure band or even with your entire player run town. But the bulk of the system is broken up into three types of quests. The first being the choose your own adventure. The second is the storybook quests, and these are community quests. If there's a scavenger hunt, you don't do it alone. If there's a need to defeat people, you don't do it alone. It's all as if the entire system is designed for group play, and it can scale up to 25 people in a group. This third part is our campaign system, and this is currently a political and large-scale war system. If you're familiar with Seeds of War, which is a tabletop tool designed to help manage virtual economics and diplomacy, we wrote a system called our PieCis, Role Play Conquest and Simulation System, a couple of years before Seeds of War came out, and we're integrating that into this game so that you'll be able to engage in political faction influence, bribery, kidnapping, coercion, combat, sea travel. So it's all really designed as one group living world. It's not broken up into individual quests for players.
That sounds really interesting.
Yeah, and
Looking
the
forward for
stories
it.
themselves. What kind of one thing on top of what she mentioned, the storyline that is generated through running these quests and doing all these things can actually be changed itself by the players. So if, say, for example, a quest says we need to accomplish A, B, and C, but the players only actually accomplish A and B, the system will know that the players didn't accomplish C, and the next push forward of the storyline will take that into account, so that players' actions and players' interactions have a lasting actual impact on the storyline of the game as it goes forward.
I
Yeah,
have
that's
dynamic tools that allow me to respond to what the players are actually doing with a weekly lag. It's not a daily lag. So I'm able to see how much progress they have made. For example, if I've put in all of these wonderful plot bunnies to do a flood on the southern part of the island, and the players decided, nah, they want to host a masked ball, and they end up getting way too many people to be in one particular area, I can, on the fly, downgrade the flood urgency and introduce additional masked ball activities around what the player is doing and support player started events by introducing new quests on the fly with less than a week's lag.
that was actually
Yep.
two of my next questions. So thank you for answering it. It's like player agency and like
Mhm.
the behind the scene GMing of the whole game. But yeah,
Yeah, our
Yep.
human SEER team handles this back-end monitoring of what players are doing, understanding what are they talking about, what are they trying to do, did they want to do something that the game didn't allow mechanically to do? We can park that for growth for next time. So it's very, very dynamic. It's got human oversight. It's all about infusing NPCs and locations with memories, with tasks, with items, and goals that they try and accomplish. It's as emergently narrative as I could design, and he could build. Thank goodness.
Well, I agree with this comment from viewer Alex here that so much thought and effort's been poured into this game. Can't wait to see the demo run on Saturday. I think this sounds like the thing I got to tip my cap on here. I mean, other than choosing an excellent technology in the form of Akka.net, other than that, the thing I got to tip my cap on is that this has got to be one of the best uses of generative AI that's not like a pure slop cannon, that I've ever, where it's like, well, I thought, Lara, you hit a really nice distinction here, which is that, the whole narrative arc of the world and the details around the story people want to immerse themselves in, you can't delegate that to an AI. There's a reason why no one wants to buy AI children's books, even. It's that like they're utterly incoherent, and not to mention boring for the most part. But so having something that has that sort of rich narrative texture, those backstories that's curated by a human who actually cares enough to go and do that, that's an important sort of segregation of duties there. But having an LLM decide how to respond to this player's dialogue in the context of what this NPC's backstory is, that's actually like a really good role appropriate use of large language models. So I think that nuanced relationship that you have between like, let's say, where LLMs are and where they aren't is a really, I'd call it good taste would be the way I'd phrase that.
Thank you. This lore has been running on our private Ultima Online server since 2007. Grimmloch's original introduction to the roleplay community was under Grimwald, Grimwoods rather than Grim Ocean. So it's had play testing. We probably had 10,000 players come through Grimwald over off and on 12 years. So it's got a lot of solid play testing. It's got a lot of base lore. I've done a fresh upgrade. The original lore was one island, and this one will have many islands, but it's all my writing. It's all the writing from our community who volunteered and added content. It's been fun trying to make sure that the LLM does not abuse my beautifully crafted world fiction.
Amen. Well, I'll put this up one more time on screen. I've also got it in the links in the chat. This is where you can go ahead and add Grimmloch to your wish list. I guess the ETA that you guys have on there is February of next year, right?
It is, but we are actively looking for play testers for the summer. We hope to open with play testing on July 4th, between July 4th and February 14th is when we're aiming for play testing. So if anybody wants to play test it, please hop into the Discord and wait for those announcements.
All right. And if you can send me the Discord link after in the private chat here, I'll go and add it to the YouTube description on this recording too, so people can go and follow you there if they're interested in the game itself, or maybe they'll have some Akka.net questions for you. So yeah, so we'll see. All right. Well, Gregorius, do you have any final questions before we sign off and close out this episode here?
Well, like I said, it'll be way too many. So I think it's better if we just end it.
I'm a little worried that Gregorius's QA is going to turn into testing. Akka.net QA is going to turn into testing your video game rather than reading GitHub issues.
Well, please come join us on Saturday for the dev chat. They usually run about 2.5 hours, and we answer almost every question that comes in.
That sounds great.
Well, thank you. Thank you, David and Lara. We really appreciate it. This has been one of the most interesting presentations we've ever done here. So thank you very much for making the time to explain your game and how you use Akka.net to power it. This was both technically interesting and also just as a consumer of video games, interesting from that point of view as well. So we really appreciate it. Go ahead and stick around here after I end the stream. We're going to go ahead and play our little outro now. And thank you to everyone who watched today. We appreciate you. We'll catch you next month with our April Akka.net Community Standup. But until then, hang out in the Akka.net Discord and check out Grimmloch if you get a chance. Thank you very much.